Good afternoon. This is Ms. Billerbeck, and we're going to look at equations involving parentheses. So let's solve this. At first, we might say, oh, that looks kind of hard. But let's first move everything that's not with the parentheses to one side. So let's first subtract this 3. Okay, so I have 6 and 2x minus 7 here over 5 equals, and then this becomes x minus 3 because I can't combine the x and the 3 because this is a variable, this is a constant, and they're not like terms. So now I need to think of, well, how do I do this from here? So what I would like to do, since I have an equal sign, it gives me the option of taking everything and multiplying by 5. So when I multiply this by 5 because it's being divided by 5, and I multiply this side by 5, so I can't do something to one side of the equation without doing it to the other. So both sides of the equation are multiplied by 5. And what happens is that cancels this 5 out. So now I have a slightly easier equation to solve. So now I just have to distribute. So I'm going to distribute these, and this one I'm going to distribute backwards. So 6 times 2 is 12, so that gives me 12x, and 6 times 7 is 42 equals, and 5 times x is 5x, and 5 times negative 3 is negative 15. So now what I'm going to do is move this 5x over here. So the opposite of a plus 5x is minus 5x. So I'm doing a SAM process. So this one is simplify, additive inverse, and we'll be doing a few of those on this problem. And then we're going to do a multiplicative inverse at the end. And I call this the SAM. Okay, so this is how you get SAM. All right, so we have 7x minus 42 equals 0 minus 15. Now I have a constant here and a constant here, so I'm going to add 42 to both sides. So I have 7x plus 0 equals, and 42 is the positive one, and negative 15 is here. So if we put it like this, it's easier to solve. So 12 minus 5, 7. 3 minus 2 is 27. So this equals 27. So let's rewrite this over here since we ran out of some space. So we're going to go up to here. So we have 7x equals 27. 7 is multiplied by x, so we want to do the opposite. The multiplicative inverse is dividing, so that's the m. So once we get to one thing here, we use the multiplicative inverse. So we divide, and we get x equals 27 over 7. And that's our answer. Okay, so that wasn't a nice answer, so I'm looking to see, did I make a mistake? Because usually they give you a nice answer. So I'm not seeing anything. So it looks like it's the right answer. Okay, can't reduce this anymore, so that's the way it goes. All right, so for this one, what we can do is we can see that if we multiply by 7 times 4, we can get rid of both of the denominators here. So 7 times 4, and if we do that to one side, we have to do it to the other side. So when we do 7 times 4, that ends up canceling like that. So now we have 4 times 2x plus 5 equals 7 times 3x minus 2. So we distribute, and 4 times 2x is 8x. 4 times 5 is 20, equals 7 times 3x is 21x, and 7 times 2 is negative 14. Okay, I think I'm going to transfer one of these problems to this. Transfer example 3 here, so we have a little more room. Isn't that one little kid screaming like bloody murder? Huh. I wonder what his mom's not doing for him. They get really mad at their mama goats. They're so funny, the little kids out there. Okay, so positive 8x, we want to move that over here. So to do that, we're going to make a minus 8x. Minus 8x. So that's 0 plus 2, 0. And then 21 minus 8 is 13x minus 14. Okay, so this is a variable, that's a constant, that's a constant. So we want to do the opposite here. So the opposite of negative 14 is plus 14. And that gives us 34 equals 13x. Well, that's not a very nice problem. So we have 13 times x, the opposite of multiplication is division, so we divide by 13. And then we get this relatively nasty fraction. Okay, so 34 divided by 13, and we can leave it right there. We wanted to make it reasonable, a proper fraction, that would be 2, because there's 2 13s in here. So we go and do it like this. So we have 2, which is 26. When we subtract, we get 8. So it'd be 2 and 8 13s if we're going to write the proper fraction. All right. Let's look at this example. So we want to solve this. Well, I am going to multiply by 3 times 4 on both sides because I don't want to deal with those denominators. Nope, this is the ninja move for getting rid of denominators. So if I multiply by 3 times 4, so that gives me 3 times 4 is 12. So I have 12z over 3 plus 12 times z minus 6 over 4 equals, and then this is 2 times 3 is 6, 6 times 4 is 24. So we can see that there are 4 3s in 12, and there are 3 4s in 12. So now we have something a little simpler. So we have 4z plus 3 times z minus 6 equals 24. All right, so we need to distribute this so we can combine some like terms. So we're simplifying for the SAM. Okay, this is also a simplify here. So we have 4z plus 3z minus, and 3 times 6 is 18 equals 24. So we're going to simplify again. So these two can be combined to 7z, and we could add 18 to both sides at the same time. So 7z plus 0 equals, and this is 8 plus 4 is 12, carry the 1, and 1 plus 2 plus 1 is 4. So we have 7z equals 42. So 7 times z is here, so the opposite of multiplication is division, so that's the multiplicative inverse. So that cancels, and we have z equals 6. Well, that was a big problem, huh? So the last problem is this. Okay, so because this is all variables, it gets a little bit challenging, but it says find A. So we want to find this little a right here. This is what we want to find. It gives us B, it gives us H, and it gives us A. So let's use substitution to find it. Oh, one thing I forgot on that last example, which is kind of important. Okay, so we did the additive inverse right here. Actually, I simplified it and I did the additive. So let's just write SAM. That's an A for additive inverse. And then this step was a multiplicative inverse. So we had our SAM. So that's important. So remember the SAM. Simplify additive inverse, and the final step is the multiplicative inverse. Okay, so back to this problem. So A, big A, is 90. So we're going to substitute 90 in there. The 1/2 stays. We don't know what A is. B is 13. And H is 9. So first we're going to divide everything by 9. And what that does is it gets rid of that 9. And it gives us 10 equals 1/2 A plus 13. Now, if I want to get rid of 1/2, I can multiply by the reciprocal, which is 2 over 1. So when we have a fraction, we multiply by the reciprocal. What that does is it takes it away like that. So we can put a 1 here. 2 times 10 is 20 over 1, which is just 20, equals A plus 13, because there's nothing multiplying A plus 13 anymore. All right, so that was a simplify. Now we're going to use an additive inverse. So this is a constant and 13 is a constant. A is our variable, so we have a plus 13 that needs to move. So the additive inverse to plus 13 is a minus 13. So this gives us 7 equals A. So our answer is A equals 7, because there's no multiplicative inverse needed since A has a 1 in front of it. So we missed out on the M part because we didn't need it. All right, so that's it for section 5.2. Have a wonderful day.